I don't know why.
All right. I mean, that's not a big deal at this point. So.
Yeah, let's not move.
Okay, I'm going to start.
Go ahead.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and welcome to PKA Technologies Software-Defined Networking Tech Talk. I'm David Singer, the Director of Marketing at PKA, and I'll be the moderator during today's presentation. For now, please enjoy a virtual cup of coffee, and be sure to stay to the end of the presentation and complete the survey. At that time, you'll have the opportunity to let us know which brand of coffee you prefer, and we'll send you a gift card so you could have a real cup of coffee. Following the presentation, we'll provide you with a link to a copy of the slides, and a recording, as well as a copy of Gartner Reports, the Magic Quadrant for Data Center Network Infrastructure. Software-defined networking is one of the latest developments in the network market. There is good reason why you and others are interested in SDN. Implementing SDN provides for greater accountability, flexibility, and quality control, and most importantly, will aid in reducing operational costs. Today we are fortunate to have Mike Zagarsky from Hewlett-Packard join us. Mike is a senior network architect and has over 15 years of experience in the networking marketplace. In addition, we have Steve Botlagador, an HP networking specialist, who will provide his industry insights. At this time, I'm going to turn the presentation over to Steve, and he will take us through this conversation. Thank you.
Thanks, David, and good morning, everyone. Thanks for taking some time out of your day to join us here. Let me just, do I have control here, David?
Yeah, you should have control.
I don't see the slides, David.
All right. You know what? I'm going to advance the slides for now while we work in the background. Okay?
Sure.
So we're on your cover slide, and if you want to just tell me when to advance slides, that would be fine.
Okay, thanks. Okay, sorry for the technical stuff there. Okay, if you can advance to the first slide, David.
We're there. We can.
Okay, okay, so let's get started then. So I want to start really by giving everybody a perspective of where we've been in the data center. I'm going to speak really about trends in the data center and how they're touching upon SDN, and then Mike will get specifically into SDN technologies, applications, and so forth. So what we're seeing, what we've seen starting about 5 years ago, you may have heard the term called converged infrastructure. And what does that mean? You know, it really, when that term came out, HP was one of the forefront of using that term. And what we were trying to accomplish, and the others in the industry were trying to accomplish, is really bringing together the areas of compute, storage, and networking into pools of resources that you can access as a single entity. Prior to that, in your environments, you may be familiar. You were out there buying, compute resources, networking resources, storage, and various people within your organization would have to, put those together, provision them, configure them, and it would take a long time. So wouldn't it be great if, a box showed up on your doorstep that had all three of them already pre-configured, and all you had to do was plug it in, assign an IP address, and then off you go. So that was kind of a first step, if you will. That set us up nicely for converged cloud. So cloud is the big buzzword in the industry, as we all know. It means different things to different people. But in order to have a converged cloud, you've got to have the ability to rapidly provision your data center resources, particularly your network. And then that was kind of the middle phase. And we're still, there today. And then where we're moving to is really what's called the software-defined data center. And that's all about providing applications and web services and being able to provision and program your physical infrastructure in a very rapid way via software, which is not typically done, today across your entire data center. You can do it in silos, but to bring those silos together is what the software-defined data center is really going to achieve. And so what does that mean from a network perspective? So when we had converged infrastructure, you really needed a resilient network fabric, something that would require less downtime. It provided faster virtual machine, mobility to you. When you had converged cloud, you needed network virtualization, so the ability to virtualize many network elements so you can see them as one, very similar to what we do today in the server world with server virtualization. And then with software-defined networking, to be able to take that next step and really look into the applications as well and have the network be aware of the application and be able to program the network in a very fast way. Next slide. So what is our strategy at HPE? How do we move forward with this? So very simple. It's one of simplification. First of all, we believe in open standards. So everything that we do is based on traditional open standards and interoperability, with other vendors. We believe in convergence. So whether convergence at the server network access layer or storage network access layer, and we will talk more about those later on in terms of specific products and technologies that we have in that respect. Virtualization is also a key area here. As I'm sure most of you are probably seen, over the past 5 to 7 years, virtualization has really taken off in server and storage world. Now we're starting to see that into the networking space as well. So we have be able to virtualize, again, many network elements and be able to see them as one is very powerful. And then automation through software, network management software, to be able to provide a single pane of glass view into the network and also into the data center is key. Next slide, please. So the market has also adopted our vision. Many of you are familiar with Gartner, and every year, as you know, they come out with their Magic Quadrant. Now, in past years, they have typically come out with 2 quadrants, one for wired networking and one for wireless. But in 2013, for the first time, they've combined the two. And why is that? Because really the advent of wireless. We're starting to see wireless become more and more pervasive, out in the market. When we're seeing new deployments at particularly new buildings or refreshes at the edge, customers are coming to us and want to be able to put in an all wireless type of solution at the campus and edge part of their networks. And that's really driving a lot of the upgrade cycle as far as that's concerned. And as you can see, we're very well represented in the upper right quadrant in the Magic Quadrant area. Next slide, please. So in the data center today, we have, what I'll call a mismatch. In the compute side, compute resources shifted a while ago, probably about 5-7 years ago, to a virtualization type environment, whether using VMware, Hyper-V, any of the major platforms out there. And it's very well established. If you look at the industry records, somewhere between 65 and 80% of the workloads are virtualized, depending on the environment. So it's considered a mature technology. It's very scalable. It's very programmable. It's very easy to deploy servers in a very automated fashion, and we've been doing it for a long time, so nothing new there. Then we move over to the storage side, and as you can see, if you can advance the slides, David, and you can see the same holds true in storage, right? We've similar type of scenario. Virtualization is very prevalent. You can manage multi-vendor storage environments in a fairly reasonable type of environment. And both of these are really what we call cloud ready, right? So we can deploy compute and storage resources very quickly to get a cloud up and running very fast. However, that's not been the case for networking. We are still stuck in very rigid type of provisioning environments, CLIs. There's not a lot of GUI infrastructure. At the end of the day, there's no real fast way to provision a network. You've got to touch every single box out there, and it's quite time-consuming and quite complex as well. If you can advance, David, and advance again. So to be able to deploy a new service, what should take in a matter of hours or weeks may end up taking, or hours could take weeks or sometimes even months if you're in a very large environment. Why is that? Because the network is the bottleneck. You're taking a systems admin, has to constantly going back and forth between that person and network admin to ask, a million different questions about how the network should be provisioned when it should be in a much more automated and scalable type fashion. Next slide, please. So how did we get here? Let's just talk about some history real quick. If you look at the evolution of server architectures on the left side of the slide, in the 80s and 90s, this world was highly proprietary. No matter what vendor you were, whether you were HP, IBM, Sun, all the major server vendors were like this. We were running proprietary hardware, chips, designing our own chips, running proprietary operating systems. Certainly Unix was out there, but everybody had a different flavor of Unix. We had HPUX, IBM had AX, Sun had Solaris, and all down the line. Linux in the 90s was just getting off the ground, and quite frankly, Intel, who was very well established on the desktop along with Microsoft, was really also just getting off the ground from a server perspective. There was talk in the 90s about, hey, can the Intel architecture scale, and can Microsoft scale to really do what we need them to do on the server side? Of course, the answer we know now today is yes, but 15, 17 years ago, these are the discussions that were going on. But we have since, as you know, moved from the proprietary server world to a Intel x86 world, also running, Linux and Windows, and the ability for an application vendor to have innovation very quickly. So in the past, if you were someone like Oracle, you had to rewrite your database 3 times for the different operating systems that were out there. And now there's still some of that, but the apps vendors can kind of write once, so to speak, and have their app run on multiple platforms in a much easier fashion. Next slide. So if we contrast that to what's going on in the network world, we are still stuck on the left slide as the server world was, in 20 years back. Whether it's us or anybody else, we see the industry move toward. Next slide, please. Okay, so I'd like to turn it over now to my colleague, Mike Skarsky, who will take you through SDN architecture and applications.
Okay, good morning. So I'm going to talk about SDN as it specifically applies to networking, right? So, literal definition is pretty simple. The idea of software-defined networking from a networking device, right, whether it be a wireless device or a switch or a router, is to basically take the control plane, right? And the control plane is kind of the engines of the brain of a switch or a router, and separate it from the data plane, right? So what's the data plane? That's the plane that's handling all the ones and zeros, right? And the idea here is that if I can remove the control plane out from the data plane within a switch or routed environment, I have the ability to create a centralized, controlled intelligence, right? And we basically call this a software-defined networking appliance. HP specifically has a software appliance today, but to remove the intelligence from all of those disparate switches and routers within my network, allows me to control my network and change my network as my requirements change and my applications need to adapt. So you can move on to the next slide. Right. So what does that mean? So what it really means is that I have the ability now to give control of my network to an application. And if I paint kind of like a real world scenario type of situation, right, that hopefully everybody can relate to. Let's take emergency management as my application. Right. Today what happens? Somebody calls 911 and there is an ambulance or a fire truck dispatched. An ambulance or fire truck, comes out of the firehouse, goes down, let's say, 5th Avenue in New York City. And as that fire truck approaches a red light, right, transponder in the front of that truck corresponds or communicates with the red light, has that red light turn green, and then for every subsequent red light, right, the transponder in the fire truck, says, hey, red light turned green so I can go through it. And then as that fire truck passes through those green lights, the transponder then communicates back and says, hey, go back to your normal operation. That's kind of what we have today. Well, with SDN, from an applications perspective, now imagine somebody calls 911, and the 911 responder knows where the origination of the call is, knows where the firehouse is, and based on that information, just by the caller initiating a phone call and the responder answering the phone, right, now the emergency management application can reach out to the network. In this case is the road system of New York City, let's say 5th Avenue. And now it doesn't have to wait for that fire truck to roll down the street, right? It can automatically set those lights up, right, for what it knows is going to happen. And then when that fire truck passes and gets to its destination, right, the network, or in this case, the city traffic lights, go back to normal operation, right? So we're really enabling, from an application perspective, for the application to reach out, right, touch the network, change the network, right, adapt the network to whatever its requirements are, and then when that need has been removed, right, that network can go back to its normal, quote-unquote, day-to-day operation, right? So that's really kind of the idea of SDN from a networking perspective. You can go on to the next slide. In fact, you can skip through this one. So with that said, you take that and you couple that with HP's Flex Fabric design, right, which the idea here is to take traditional 3-tiered networks, right, access, distribution, and core, and break them down into 2-tier, right, whether it's leaf and spine or access and core, right? The idea that we're seeing, or what we're seeing really in the data center, is less of a north to south and more of an east to west traffic flow, right? And that's just because more and more applications and databases are relying on each other for information, right? So the idea is to bring simplicity and reduce complexity within the networking infrastructure environment. You can move on to the next slide. So HP is really a leader in the SDN network world. With that said, we have a software-defined networking kit that anybody can sign up for. We also have a very newly released SDN app store. And the mentality that we want to bring to the marketplace is to be open, right? So we're using OpenFlow, and the idea is to just create an open environment where anybody can come in and create applications for us today, and us and the customer base. Like I said, we have 8 apps today in our store, and I'll cover 2 or 3 of them as we go through the presentation. You can continue on to the next slide. Right. So where does a software-defined networking controller sit within the overall architecture? Well, it basically sits in between the application layer and the network, right? So again, go back to the root definition of SDN from a networking perspective. The idea is to remove the control plane from the data plane, right? So today, HP has over 50 switch platforms that support OpenFlow 1.3. We've got, I think, in excess of something of 20 or 30 million deployed OpenFlow and ready-enabled Ethernet ports. With that said, the controller will sit out there within the infrastructure in between the switches, routers, and the applications. So as an application has a requirement from a networking perspective to maybe change something like network virtualization in conjunction with VMware, or maybe something with the unified communications, which I'll touch on, the application reaches out to the VAN controller, and from there the VAN controller then reaches out to all the disparate switches in the network, right? So, as a case in point, if you wanted to roll out voice over IP, and you know that you're going to have to set up new VLANs across all of your switches, you're going to have to set up quality of service across all of your switches. Instead of having to log into anywhere from 20, 30, 100, 500 disparate switches around your network and make those changes, wouldn't it be nice to go to one central location, i.e. the software controller appliance, make that change, and then that change is pushed out to all of your network devices, right? So again, it goes back to simplicity. You can move on to the next slide. Touching on the application that we call the Protector SDN, the idea behind our Protector app is to have centralized intelligence for intrusion protection, right? So HPE now has tipping point and ArcSight, and instead of deploying a standalone appliance within the network, you have the ability by running our SDN controller and the Protector app is to take that tipping point and ArcSight intelligence and push it out to the edge of the network, right? So here we allow a customer, right, to implement an intrusion protection scheme within their networking infrastructure, right, from a software perspective. You can go on to the next one. Another example of a SDN app that we have is for Optimizer, and that works in conjunction with Microsoft Link, right? So the idea here is right, Microsoft Link is a UC&C type of application that supports voice, data, video, messaging, etc. We all know that when we're sending that type of traffic across our network, things like quality of service are key, right? So the idea behind the Optimizer application is that as calls, whether they're video calls or audio calls, are set up and torn down within the networking infrastructure, the Optimizer app is aware of this, right? So the Optimizer app within our controller works in conjunction with the Link server, right? As the calls go up, the Link server communicates to the Optimizer application. From there, the SDN controller reaches out to the network and creates quality of service for that call, whether it be a voice or data call. And then when that call is dropped, right, the Link server in then turn works in conjunction with the SDN controller and changes the networking parameters, i.e. the quality of service, and takes them down, right? So you've got real-time network change based on an application requirement, right? You go on to the next slide. So our integration with VMware, right? So this is where this is a huge differentiator that HPE has within the SDN networking environment. And what we do here is that we have a federation between our VAN SDN controller and VMware NXX, right? So if you take a look at our competitors, our competitors do a lot of the similar things that we do from an SDN network controller perspective, right? Where I have a single point of control, I make some, I create an API or a quick script. I can go out there and change QoS and VLANs to various types of switches, routers, assuming they support OpenFlow. What they don't, but from a competitor's perspective, it's very static, right? Very static when I take a look over into the VM world. The difference that we bring to the table is that because we're federated with the VMware NXX controller, we become a subordinate, right? So, as you make changes in the VM world, whether it's I need new VLANs, new networks, I've got to do vMotion from point A to point B, and I need to change my network, right? We will listen to that NSX controller, and we will create that networking infrastructure real time as it's needed, right? What our competitors do is right, they create a networking infrastructure with their controllers. They have to, more or less manually take that information, feed it into the NXX controller on the VMware side, and then the the VMware NXS controller has to live with those parameters, right? There are no hooks in between what our competitors are doing and what VMware NXS are doing, right? But with HP, the HP solution, there are, right? So the idea here is taking SDN and really, making it a ubiquitous type of technology that really goes from the data center all the way out to the access of the networking infrastructure. You can continue. Right, so our networking portfolio, HP makes everything from wireless access devices, controllers, right on up to core switches and routers, right? So, we've got it in the marketplace. We have security appliances, hardware, software, next generation firewall, intrusion protection type devices and appliances, and last but not least, we also have a management suite from a networking perspective called Intelligent Management Center, which we call our single pane of glass, that can not only manage and maintain HP devices, but 200 various different vendors in the community today. So we've got a full suite of networking products. We don't need. You can continue on. I'm just going to go through these fairly quickly, right? So this is a 6125. It's our blade switch. The idea here is to remove a hop from your network, right? So I take blade switch, I throw it into a C7000 as an example. It's a full function layer 2 switch, and basically it removes that extra hop in your network going from 3-tier down to 2-tier, for that east-west type traffic. Supports several 40 gigs as well as several SFP plus or 10 gig interfaces. You can go on to the next slide. So our FlexFab 5900 switch series, we've got about 4 different models of this guy, and they're basically focused on top of rack, anywhere from 1 gig, 10 gig on the access with 40 gig, northbound connectivity. Supports all the traditional layer 2 trill. One of the differentiators that HP brings to the table is a technology called IRF, Intelligent Resilient Framework. This is our technology that allows you to take up to 9 switches and put them together logically to look like one switch, right? And it's not just the idea of taking up to 9 switches and managing one IP address. It's taking up to 9 switches, logically grouping them together, and now I only have one OS running. I only have one copy of the running config running, right? So truly we treat this kind of like a modular switch, right? Brings a lot of resiliency, a lot of redundancy. It helps with design, deployment, and subsequently day 2 support within the top of rack environment. And we support IRF across all of our Commware switches today. You can go on to the next slide. The 5700 top of rack switch is something we just launched about 2 months ago. And the idea here is basically to be a port extender, right? So this is a lower cost top of rack switch. It is a traditional layer 2 switch, right? But the idea here is for it to be subtended off of, let's say, a 5900, kind of like a leaf and spine type of design. With that said, where we differentiate from the competitor is that it can be a standalone layer 2 switch. It is not dependent to run, under a 5900. And we have an additional IRF technology called Enhanced IRF, where I can hang up to 24 5700s off of a single 5900, and they all look like one switch, right? Again, it's that idea of how do I design, deploy, and do day 2 support from a very economical and efficient manner. And again, one IP address, one copy of the running software, one copy of the configuration, right? So in essence, when I do a situation like that or a scenario like that, I'm kind of basically looking at a large modular switch, right? But I've got the flexibility with the whole stackable and top of rack environment. You can move on to the next slide. So the 5900 CP stands for Converged, and the idea behind the CP was to support not just fiber channel over Ethernet, not just iSCSI and Ethernet, but also native mode fiber channel. So the big takeaway here of the CP is that it's part of the 5900 family, but the optics that we are using in it, within the single SFP optics, we can support 10 gig Ethernet. We can support 2, 4, or 8 native mode fiber channel, and it is software programmable, right? So I can take this switch, I can put it in the top of rack, and I can interface directly with my storage area networking if I want to. From an end user perspective, think of it from an inventory kind of train of thinking is that, you know, if I've got X number of ports that need to do fiber channel over Ethernet, maybe X number of ports that have to do Ethernet, X number of ports that have to do native mode fiber channel, I'm using the same optic. Right? I'm not having to worry about, oh boy, I've got, you know, four fiber channel interfaces on my switch. I better make sure that I spare a FET. No, the optics that we're using are software programmable, and you know, to date we are the only vendor in the marketplace that supports that multi-protocol over one optical interface. That's a huge differentiator. You can move on to the next slide. Right, so, and this is where I talk about converged optics. So, right, again, the idea here is that I have one box that can support all these disparate types of technologies within the data center environment. So that's all I have, you know, specific to HPE SDN and our product set. So thank you.
Well, thank you, Mike, and thank you, Steve, as well. I'm going to ask that if there are any questions, if you could just type them into the box on the upper right side of your screen. I'll go ahead and ask them to Mike and Steve. And while I'm waiting for any questions to be submitted, let me ask you guys this question and kind of see if I can summarize some of the things that I've heard, and maybe you can address it. And that is, there's a lot of people talking about SDN, you know, and where does HP differ from the other vendors, and how does HP play if somebody already has a Cisco infrastructure? Will you play nicely with them?
You want me to take that, Steve, or you want to take that?
Go ahead, Mike.
So we differentiate a couple ways. One, we've gone into the SDN marketplace with the open mentality, right? So, you know, we were a co-author of OpenFlow back with Stanford University. I believe it was 2006, 2007 timeframe. So the idea here is we don't want to lock anybody in or paint anybody into a corner that basically says, hey, you're going to go with me as a vendor, and you're stuck with my proprietary solution, right? So that's our first differentiator. You know, with that said, we're not the only vendor in the marketplace that has OpenFlow. We are the largest vendor and have the largest number of deployed OpenFlow-enabled switches and ports. You know, so there are other guys out there doing something very similar using OpenFlow. You know, that's one differentiator. The second differentiator is because we are the leader. I firmly do believe that we are the leader with things like our SDN design kit that anybody can go up and sign up for. Our application store is that we're bringing to the marketplace, you know, an ecosystem, you know, that hopefully, you know, many more vendors and customers are going to come in and create applications, and we seem to be one of the only ones doing that. You know, with that said, because we're doing that, we continue to be a leader on the application side, right? If you take a look at our integration with VMware, right, with NXX, we're the only ones that are doing it, right? To date, not saying I'm sure there's going to be others that come in behind us that say, hey, that's a great idea, or I have a better way to do it, or what have you. But I think today, you know, our two differentiators are the fact that we are using an open standard. You know, we help offer the open standard. We're a big proponent of that. Everything we do is open, whether it's Open Daylight, Open Flow, Open Stack, right? There's a whole bunch of opens out there, quote unquote, you know, specific to the data center and software-defined networking. And I think as we continue to be the leader, you know, we're gonna bring out, you know, some more compelling applications to the marketplace that help, you know, continue to differentiate us from the competitor, right? Our biggest competitor, right, is pushing their just to you know shoot a bullet across their bow. Our biggest competitor is coming to the marketplace with what I call a very vendor-centric solution, right? Which is what everybody's kind of used to dealing with them. So we're coming at it from a different perspective. To answer your question in terms of, you know, can we work with other vendors in the marketplace if somebody's got a deployed infrastructure? Well, the answer there is yes and no, right? So, you know, SDN from a networking perspective really is about the edge. it's about pushing intelligence down to the edge, right? Right. So if when do I want to catch something in my network or make a change in my network? I want to make it as soon as that Ethernet frame or that IP packet hits my network, right? At that ingress Ethernet port, right? So with that said, if somebody has a, let's say, 100% other vendor deployment, the reality is unless they support OpenFlow, OpenFlow is not going to work, right? In an SDN network environment that relies on OpenFlow, it's just not going to work, right? I'm not gonna mislead you about that. But if you do have a combination of HP and another vendor, and HP is sitting on the edge, again, the idea of SDN is to push that application requirement change within the network to the edge, right? Because that's the first place. I want to either put quality service on my traffic or block my traffic or whatever. So you can have HP SDN work in a hybrid environment. It really depends upon what the overall architecture looks like, and where you put the switches and or routers, etc.
Okay. Thank you, Mike. I don't see any other questions, so I thank everyone for attending, and I just want to go into a wrap-up phase and just kind of talk a bit about PKA. So for over 20 years, we've supplied enterprise IT solutions within the tri-state area and to both corporate and public sector clients. PKA is an HP authorized partner on the New York OGS contract and the New Jersey WSCA contract. And these partnerships with HP and other vendors, I think, really uniquely enable us to solve client infrastructure problems and challenges. And at this time, what I'd like to do is introduce our Director of Enterprise Solutions, Russ Chow, so that he can give you a brief overview of our technical capabilities. Russ, why don't you go ahead, and I'll advance slides for you.
Thanks, David. Appreciate everyone. I can see that I think we've gone over quite a bit, so I'm going to try to make this short and sweet. But I'd like to, first of all, thank you for joining today's webinar, and I hope you found it beneficial, and hopefully provided you with insight into how software-defined networking is to building a software-defined data center based on a new style of IT. I'd like to talk a little bit about who PKA is. David kind of started that off, but basically PKA is an IT infrastructure integrator. What that means is we're focused on architecting and deploying solutions that help our clients reduce cost, improve performance, and mitigate risk. We are a proud member of a few advisory councils, Intel as well as HP, and our executives sit on these councils where they gain insight into the futures and strategies of our partners, and also serve as our customers' voice back to the manufacturers with respect to product enhancements and improvements. So we find that this really helps us to determine how our partners are going to market and what's important to our customers. We've also forged strong alliances with many of the ISVs, including those below that you see on the slide here. That allows PKA to leverage unsurpassed product knowledge and service to solve our customers' infrastructure and complex solution challenges from the desktop to the data center. Just want to go through some of the subset of some of the solutions that we provide to our customers. Again, it's basically everything within the four walls of the data center, but just to touch on a few, from a storage perspective, we have offerings for storage consolidation, virtualization, and optimization, as well as backup and recovery and data management. And from a virtualization perspective, around servers, networking, storage, applications, virtual desktops. And big data is very important to our customers. We've got a focus around data analytics and SAP HANA. And on the security side, tying all that back to all these applications with respect to intelligence, risk management, and data protection. And then the cloud services, infrastructure support, and application consolidation, as well as data center optimization within the cloud services space. David? And as you can see, we offer a myriad of services. I won't go through all of them. You can kind of read the slides, but a lot of assessments and evaluations across the entire infrastructure stack, migration services, management services, installation and implementation, data center relocation, as well as colo facilities, and training, as well as architecture and design. At our office, we have a state-of-the-art demo center, which we open up to our customers, and they find it very beneficial that they have a place where they can go to do some testing of applications, evaluations of products, proof of concepts, benchmarking services, as well as live and remote demonstrations. So this is something that we offer out to our customers, and seems to provide a lot of value to them. So that's about all we have. Lastly, I would just welcome the opportunity to meet with you to further discuss your networking requirements and determine how we can potentially help you with any projects and initiatives you may have. And again, thank you for taking the time this morning. Greatly appreciate it. And David, I'm going to hand it back over to you.
Thank you, Russ. Before I close the call, I just want to remind everyone that we'll be sending out a link to the slides and a recording. We'll also be sending you a copy of Gartner Report's Magic Quadrant for Data Center Networking Infrastructure. So please just be sure to complete the survey that follows the close of this session. Make sure you tell us which gift card you want so we can send you a card. You'll have a nice hot cup of coffee. And mark down on your calendar our next Tech Talk, which will be on October 21st. And we'll be talking about the HPE Enterprise Network Security products. Once again, thank you all for attending.